your monthly dose of astronomy news and views. This is Awesome Astronomy.
Hello and welcome to Ep.19 of Awesome Astronomy. We well and truly put 2013 to bed in our end of year special and given away some fantastic prizes, but now we have a new dawn to look forward to. With both feet placed firmly in 2014, we wish you all a happy new year, and we can only hope that this year provides as many space and astronomy highlights and serendipitous surprises as last year. But it'll come as no surprise to our regular listeners that joining me to propel ourselves into the future is Paul.
Hello! Happy new randomly selected for no obvious astronomical reason beginning to another orbit of the Sun. Yay!
Now, first up, we'd like to thank Astronomy Now and the European Southern Observatory for offering some extra Christmas presents to our competition winner, Sam Blayan. Those are winging their way to you if they haven't arrived already. And we already have a competition lined up for next month with more goodies from our friends and wonderful supporters at the European Southern Observatory. I've already got those prizes and I don't want to let them go, but more of that next month. And secondly, we have to congratulate the European Space Agency on their flawless launch of the Gaia spacecraft this morning as we record. For all of you in the future, that was the 19th of December 2013. So, Paul, Christmas was a time for shameless commercialism and marketing-inspired joy, but now we're in January and we've got the season of traditional penitence. Any astronomy-based New Year's resolutions?
Oh, well, I have some mad notions of getting back to basics and trying a bit of Gaia-inspired star mapping. I have some crazy plans to make my own planisphere.
Right.
Yeah, and I'm determined to get stuck into the Herschel catalogue and get sketching some of the many objects the greatest amateur astronomer listed. And a successful tripod invasion of the Earth. That's to be high on my list. Yeah, don't say I didn't warn you, Earthlings. What about you?
Well, it's my resolution to get back to dark sky imaging again this year. Over the past year, I've been experimenting with imaging through heavily light-polluted city skies, but I'm going to get away from the orange glow of Cydonia and return to imaging faint fuzzies with more regularity, so I'm really looking forward to that.
Oh, yeah, I look forward to the results of that over the next 12 months.
Now, this year, we're making one small change to the format of the show, and a change that means you get more awesome astronomy for your buck.
Ooh, are we charging them now?
No, and we're giving them an extra show each month too, so we'll have the main show on the first of each month as normal, but we'll also have a full Sky Guide on its own going out a few days before the start of each month.
So you'll get the Sky Guide ready to download, or downloaded automatically if you subscribe via iTunes or the RSS feed on the website, in enough time to plan your evenings observing before the month starts.
And our web guru is packing the Sky Guide with graphics and visual guides to help you locate objects, show you what you can expect to see, and, well, take a look for yourself on our YouTube channel.
Just look for Awesome Astronomy,
where the graphics and animations accompany the podcast. So bringing you the last Sky Guide as part of the main show, it's over to Paul to share with you the magnificent objects above your head at the beginning of 2014.
This is Awesome Astronomy.
January, and we start the year with long dark nights and a sky dominated by the large bright winter constellations, while on the 4th, Earth reaches perihelion, and it's at its closest point to the Sun. This month we have a planetary opposition to hold our attention, a decent meteor shower, and 2 new moons. As has been the case for the last couple of months, Jupiter is dominating the sky at present, and on January the 5th it reaches opposition, and will be at its closest to Earth. In the weeks following opposition, we should get some great views of the King and be able to get our best views of the moving cloud detail, and of course the Great Red Spot. With nights at latitude 50 lasting more than 10 hours, now is the time for the hardy impatient to observe the full rotation of the planet, as well as see the moons move in their orbital ballet. Of course, with Jupiter's inner moon, Io, taking less than 2 days to complete an orbit, over the course of a single night you will see it move a considerable distance. One of the most interesting phenomena you can observe is the transits of the moons, as they and their shadows cross the planet's face. The wonderful moment when you realise you are watching the shadow of a moon crossing the face of another planet is one not easily forgotten. They're regular transits, but for evening observers in Northern Europe, good opportunities in January will be Europa on the 1st, Callisto on the 3rd, Io on the 15th, and Ganymede on the 25th. Look for timings on our website. Other planets are less impressive than Jupiter this month. Uranus and Neptune are beginning to be lost in the evening, and both are now well past opposition, so providing very small disks to observe, but can be found in Pisces and Aquarius respectively after sunset. Mars and Saturn are still for the early risers, and while Mars is achieving a reasonable altitude by dawn, the disk is still very small, and we're still a long way from opposition. Mercury begins the month away from our gaze close to the Sun, but as the month progresses, the messenger climbs into our evening sky for a brief appearance after sunset. It will be close to Neptune and a thin crescent moon on the evening of the 31st. Venus does a swap during January, trading its recent evening star position for the morning. This means that for the middle of the month, Venus will not be visible. When it returns in the morning, it will be blazing away at minus 4.19, an incredible spectacle for the early risers. The moon manages to squeeze in 2 new phases this month. We start with a new moon on the 1st and end with another on the 31st. This of course means full moon occurs in the middle of the month, on the 16th. So get your deep sky observing nights in at the beginning and end of January. The start of January sees us under a nice meteor shower, the Quadrantids, which peak on the night of the 2nd and 3rd of January. With the moon out of the way, we should be able to enjoy the hourly rate of around 40, and in the past has contained many bright trails. This is thought to be the dust of extinct comet 2003 EH1. The radiant is located in Boötes, the kite-shaped constellation with bright star Arcturus blazing away at the base of the kite. But meteors can appear in any part of the sky, which is lucky because Boötes is low in the sky this time of year. Our tip is to stare at the sky between the constellations of Ursa Major and Leo for your best chance of catching these meteors. Moving on to our constellation and deep sky recommendations for this month, and being January, it's time to talk about the Hunter and his main dog, Orion and Canis Major. Orion is perhaps the favourite playground of amateur astronomers. The whole constellation is set against the closest active star formation region to Earth, and has something of interest in every corner. Locating the famous belt, themselves part of an open cluster known as Colander 70, are made up of the stars Alnitak, Alnilam and Mintaka. You can find the famous Horsehead and Flame nebulae, IC43 and NGC 2024, near the easternmost star, Alnitak. These are very difficult visual targets, but moving north you should be able to locate the poor relation of Orion nebulae, M78, looking like a dim comet-like smudge with the variable star V351 Orionis. Moving back to Alnitak, you should be able to locate a glorious multiple star feast in the form of Sigma Orionis and Struve 761. Sigma Orionis is a 5-star system, the splitting of which will depend on scope size. Small scopes should be able to manage 3 stars, while medium-sized scopes should manage a beautiful quadruple split. Very close on the same view is the triple system Struve 761, a bit fainter and forming a pleasant triangle. Below the belt is perhaps one of the jewels in the astronomy crown, Orion's sword. Even naked eye, there is obviously something special about this patch of sky, and it seems to demand our attention. Right at its centre is the Great Orion Nebula M42 and M43, with the stunning trapezium cluster right in the middle. Binoculars of even low power start to reveal the nebulosity, while the view in a scope is almost never short of breathtaking, even in light-polluted skies. Moving below the sword is an overlooked curiosity in the form of NGC 1999. This is a bright nebula known as the Empty Hole Nebula, because of the dark keyhole-like object in its centre. It was thought originally to be a dense dust cloud, but recent observations have shown it to be a very empty bit of space. Before leaving Orion, it's worth mentioning Barnard's Loop, a vast looping structure that can be imaged or seen in very dark skies, sweeping around most of the constellation. It's thought to be a result of a supernova that exploded 2 million years ago, and is currently 300 light-years across. Canis Major sits at Orion's eastern foot and should be very easy to locate due to the presence of the brightest star in the night sky, Sirius, which blazes away at magnitude minus 1.46. The dog star is not particularly big and is bright due to proximity, at only 8.6 light-years away, and has a white dwarf companion which can only be split in a very large scientific telescope. An interesting historical fact is that Sirius is the origin of our phrase, the dog days of summer. As the sun sits in this part of the sky in the summer, it was thought that Sirius was adding its light and heat to the efforts of the sun. Wrong, but the origin of a long-standing phrase. Canis Major is a constellation often overlooked by more northern observers, which is a shame as it contains a nice open cluster in the form of M41, which is easily found in binoculars and contains a beautiful scattering of orange stars. There are also several smaller open clusters, such as NGCs 2367, 2383 and 2384. For those with larger scopes and the imagers, there are a nice scattering of galaxies in the form of 2207, 2223, 2217 and 2280. That is all from this month's Sky Guide, and don't forget that next month's Sky Guide will be released as a separate download available a few days before the end of January. Remember to wrap up warm, and I wish you clear skies.
This is Awesome Astronomy.
Thanks for that, Paul. Now on to the news, which is a nice mixed bag of events occurring over the last month, and we'll start by picking the bones out of Comet ISON's Herculean attempt to survive the ravages of the solar maximum.
Okay, let's try and put a positive spin on this because it's not a happy tale in many ways. Though I might add that I told you so.
And I think I owe you a pint. But yes, we can draw positives because firstly, it was a comet that was observed by a staggering number of telescopes, from an early sighting by NASA's Deep Impact spacecraft designed to study another comet, to the Messenger spacecraft in orbit around Mercury, and a whole host of scientific instruments from ground-based infrared and radio telescopes to the barrage of sun imaging spacecraft that allowed us to chart its passage around the sun.
Or not, as it turned out.
Yes. Disappointingly for anybody that would have liked to see a comet in our evening skies this and last month, ISON does appear to have fizzled out, but that's not the whole story, and I'll come on to that in a minute, because another positive we can take from the ISON saga is how involved people got when chronicling the comet's approach to the sun, and how vibrant the social media channels became. We were both glued to NASA's online coverage of the event as we frantically refreshed the stereo and SOHO spacecraft images that were updating us on ISON's perilous journey. And Twitter and Facebook they were filled with excitement too. So this shows NASA and ESA how much real-time interest there is in space activities, and I hope this will spur more live events for future missions and astronomy events. I guess we'll have to wait and see if this happens.
Or we could host some Google Plus Hangouts ourselves.
Not a bad idea. We could get some project scientists from NASA and ESA to join in, and maybe a few space and astronomy bloggers too. That could work.
I think that could.
But anyway, what do we know about ISON's disappearance? Well, while the spacecraft that were charting its passage around the sun showed that something re-emerged on the same orbital path as ISON, but calling it ISON really is just for convenience, because the comet was hit by severe solar storms and tidal forces that broke the 2-kilometre snowball apart just before it reached its closest point to the sun on the 28th of November. And looking at the SOHO images in near real time, we could see this breakup happen, but it happened so close to the instrument's coronagraph, the part that blocks out the intense glare of the sun to allow us to see the fainter details, that we couldn't confidently say the game was over until we saw what re-emerged on the other side of the sun. And we waited for these images with bated breath. And nothing. We saw nothing of ISON, so confidence quickly grew that it had been blown apart, until a series of SOHO spacecraft images revealed a diffuse but clear object following ISON's orbit away from the sun. So something had survived, but because it wasn't bright enough to be an intact comet, it could only be fragments, remnants, dust and rocks. NASA's Goddard Space Flight Center gave it a 10% chance of containing chunks larger than 100 metres wide, but a 90% probability of being a conglomeration of much smaller, sub-10 metre wide rocks. So ISON raced towards the sun, reaching 850,000 miles an hour as a 2-kilometre wide ballistic cannonball, and left its encounter with the sun as a rocky buckshot, sailing back on its long journey out of the solar system in pieces, never to be seen again.
But we can lighten the mood again, because firstly, you owe me a pint, and because also there's loads of scopes still studying these cometary fragments, and although it's harder to see, as it's not as bright as an intact comet, it should reveal more about its composition now that it is in pieces.
Yes, we've had the small low-cost European Proba 2 satellite finding little water in the remnants. Hubble's taking a look in, and NASA's infrared telescope facility in Hawaii has dedicated spectrographs to further analyse the elements present in the gases around the travelling debris. So while perihelion events suggest there's little water or nucleus left from ISON, there is still tons to learn about this Oort cloud object, and still a few faint amateur observations to be had, as vented gases still form a dim coma around what was Comet ISON.
Yeah, so not a naked eye comet, not an impressive telescope or imaging target either for amateur astronomers, but probably more of a nostalgic glimpse of this faint object as it limps out of the inner solar system.
Yeah, exactly. And if you can find it, it really is very dim now. So next up, we have the latest Chinese spacecraft to make its way to the moon, following the Chang'e 1 orbiter in 2007 and the Chang'e 2 orbiter in 2010. Next up is the Chang'e 3 mission that launched a lunar rover on the 2nd of December, just last month, and its successor, an improved rover, is then scheduled for launch in 2 years' time. This paves the way for China to attempt its first lunar sample return mission before 2020 with Chang'e 5, and hopes that Chinese taikonauts will take their first step on the moon sometime between 2025 and 2030.
So as we record this, the spacecraft is already there and carrying out its mission.
Yeah, it is. The orbiter went into a 100-kilometre high orbit around the moon on the 6th of December, and the lander, named Jade Rabbit from a Chinese myth and selected in a public vote, touched down in the Bay of Rainbows on the 14th of December. Incidentally, the Bay of Rainbows, or Sinus Iridum, is a lovely 3.5 billion year old lunar feature carved by a giant impact meteor on the western side of the Sea of Showers, which is filled with lava to form a bay on the edge of the sea. It's visible with binoculars or a small scope and really is a beautiful sight on the nights of an 11, 12 or 24-day-old moon.
And while the bay is well worth looking at through a scope, you won't be able to see the rover as it's far too far away to be able to resolve something of that size, I'm afraid.
Yeah, that's right. In fact, I think that NASA's incredibly detailed images from the Lunar Reconnaissance Orbiter can only see this Chinese rover as something like 2 pixels across. But this new solar-powered rover that's a little bigger than the Apollo Dune buggies carries an infrared and an X-ray spectrometer to study the elements present on the lunar surface in this unexplored part of the moon. It then has a ground-penetrating radar that listens for high-frequency echoes from pulsars sent down to a depth of hundreds of metres to study the depth of the lunar regolith, that's the grainy soil from meteorite deposits, and the subsurface to a much deeper level than either the Russians or Americans in the 1960s and 1970s. And these specific instruments have led many in the West to assume that Jade Rabbit is lunar prospecting, looking for elements and minerals, particularly helium-3, which is rare on Earth, but was found in abundance on the Moon during the Apollo missions, and is ideal for fusion power reactors when you ever build one.
If you ever build one. It's really easy, humans, come on.
But I think that's unlikely to be a key mission aim when so much is already known about the lunar mineralogy. And why mine the Moon when you control so much of the Earth's supply of valuable minerals anyway? But anyway, back to the instruments, and next up is, of course, the crowd pleaser for the public.
Laser beams and heat rays!
Well, I was thinking more like 3D cameras.
Well, they're pretty cool too, I guess.
But its other goals are exciting for the astronomers because it'll be the first moon observatory. The lander itself has a radioisotope heater that'll keep the solar-powered rover warm during the moon's 330-hour-long nights. It has panoramic cameras to take images of the moon and will also make observations of how the Earth's ionosphere is affected by solar activity, with an extreme ultraviolet camera attached to a 150mm astronomical telescope, which will also allow solar system and galactic observations from the moon. How cool is that?
Now that's an observatory that's worth splashing out for.
But there's also the problem here that the propellant that the orbiter deposited in lunar orbit and the dust that was kicked up by the descent stage's powered landing is now disrupting the tenuous lunar exosphere that NASA's Lunar Atmosphere and Dust Environment Explorer spacecrafts carefully studying. But in a looking for positives kind of way, it'll also allow the NASA orbiter to learn more about the lunar atmospheric dynamics and how kicked up dust gets moved around the moon and settles. So it's quite fortuitous timing in a way. Well, maybe.
But it's not all plain sailing for the Chinese. Didn't they have a rocket go pop last month too?
Yeah, a Chinese Long March 4B rocket failed during launch on the 9th of December as it was trying to loft a Brazilian ecological satellite to monitor Brazil's rainforests. So a big setback that thankfully didn't happen on the Chang'e 3 moon launch. And don't forget that NASA had some spectacular rocket launch failures of their own too before the Mercury, Gemini and Apollo successors, so it's still exciting times for Chinese spaceflight. But the downside we get from Chinese endeavours is the secrecy that goes with it. The science details were quite scant until the launch, and we don't get to live the missions like we do with the American and European missions in particular. Though the live coverage that CCTV, the Chinese state-owned web-based media channel, put on in English was very welcome and compelling, so we did get to watch the launch, orbital insertion, rover descent, landing and exploring.
Yeah, and it's also worth mentioning that this mission had a huge helping hand from the European Space Agency, who provided vital communication support through its Deep Sky network, S-Track. Hopefully, as time goes on, this sort of cooperation will increase and make these efforts more and more an international flavour.
But then, of course, there's also the human risk to the Chinese missions, which we have to caveat with the recognition that little adverse publicity leaves China. But I'm not referring to the risks to astronauts here. As China's launch centre's landlocked, it means rockets can't ascend over the sea like NASA's do from Florida and ESA's launch over the ocean from French Guiana. But in the case of the Chang'e 3 launch to the moon last month, the China Daily newspaper reported that 180,000 people were relocated from the downrange path that the rocket had to take over land, and 2 houses were damaged as a cone and other debris crashed through the roofs. And with the number of launches rising to 20 each year, that displaces a lot of people and exposes even more to the risk of falling debris, especially if a launch explodes or has to be detonated along the strip of Chinese land some 60 miles long and 30 miles wide from the Xikang Satellite Launch Center. But before the displacements and the debris damage, quite a few media outlets appeared to give a negative bias when reporting Chinese space missions. So I took a quick Twitter poll following this launch asking people if they were worried or excited by the Chinese space endeavours. And it was interesting to see that about 80% were excited by this, which I think shows people are still very interested in space exploration regardless of which nation's doing it, though this small sample is hardly representative of the population as a whole.
Yeah, and 117% of Awesome Astronomy followers on Twitter are officially space obsessives.
Yeah, as are we. So next up in the news this month is the discovery using Hubble imagery that Jupiter's icy moon Europa is venting water into space. Now, you might already know that Saturn's moon Enceladus revealed to the Cassini orbiter in 2005 that it had cracks and fissures in its icy surface that vent water, hydrocarbons, ice and dust out into space from a suspected water ocean beneath the thick icy crust. And these geysers actually refresh and perpetuate one of Saturn's smaller rings, the E-ring. And with Europa, we have a moon that's half the distance from the Sun and thought to be one of the best candidates in the solar system for harbouring life. Now, like Enceladus, it has a thick icy crust, but we also believe it has a salty ocean beneath the surface. We only suspect this on Enceladus. But now we have the analysis of these spectrograph images taken by Hubble last year, and it's quite a piece of planetary, or rather lunar, detective work because the Hubble team have looked into the ultraviolet emissions in Europa's faint south pole aurora, and this is caused by Jupiter's immense magnetic fields. And when the water particles spew out and hit the aurora particles, they're split into their constituents of oxygen and hydrogen, and then can be picked up by Hubble to reveal the presence of water being ejected.
Yeah, that is a very cool piece of detective work.
It really is, isn't it? And it's also been suggested that fissures might exist on the surface of Europa that are pulled open and closed as the moon orbits the gas giant, because on Enceladus, at the furthest point in its orbit, known as aphelion, observed fissures open up and water rises up like a fountain under pressure and vents into space. And interestingly, it's when Europa's at aphelion that its geysers become visible too. So there's lots more for astronomers and astrobiologists to get their teeth into at Europa, and more for NASA's Juno and ESA's JUICE missions to look out for in the Jupiter system in 2016 and 2030 respectively.
And lastly this month, you're returning to a favourite subject of yours, exoplanets.
Yes, I've been deliberately ignoring talking about exoplanet discoveries for the past few months so I don't appear too obsessed and boring, but we've had a few interesting updates in exoplanetology that I think need an update. The first item to mention is a nice tale of 3 massive planets, possibly brown dwarf stars in their own right, that have been spotted as potential exoplanet candidates and then subsequently neglected for more than 10 years. And a team made of astronomers from the US, Australia and Chile conducted a follow-up study using near-infrared photometry. That's studying the light intensity and wavelength strength in the near-infrared region of the light spectrum, just beyond human sight and where large gas giants, and especially brown dwarf stars, emit their own light. So this can be classed as direct detection or imaging of large planets rather than inferring their presence from the way their host star wobbles or dims as planets move around them. And the research paper that was published last month suggests these neglected planets are there and orbit 3, 4 and 6 times further from their stars than Pluto's distance from our Sun, and their masses are calculated at approximately 10, 16 and 10 times the mass of Jupiter respectively. Now, taking into account the margins of error in calculating the mass of each of these planets, one is almost certainly a brown dwarf and the other two are right on the boundary between the largest possible planets and the smallest possible low-mass stars, which is around about 13 times the mass of Jupiter.
Good to see the gas giant brown dwarf star debate rolling on. So what's up next in your exoplanet roundup?
Observing a distant planet being swallowed up by an aging and bloated star before the star itself shrinks down to form a white dwarf star.
Sounds cool.
Yeah. So this star's going to finish up as a hot cinder of its former self, gradually cooling over billions of years, and it'll leave behind a beautiful gas cloud for any nearby alien astronomers to marvel at.
Seriously, what other branch of science or any field of study can even imagine such wonders, let alone observe and understand them?
It's just amazing, isn't it? I say this all the time, but we're so fortunate to be living now when we can know stuff beyond so many people's imaginations rather than just concocting stories to explain things and hoping no one can prove us wrong. Take this for example, the technology we now have and the accumulated knowledge of scientists has got us to the point where we can confirm the existence of a planet known as Kepler-91b, a little larger but a little less massive than Jupiter, around a star 3,360 light years away. And a paper released last month by a European team in collaboration with the European Southern Observatory in Chile found something exciting and new about this planetary candidate. That in 55 million years, this gas giant planet will be engulfed as its dying star continues to bloat. The effects of this are already being witnessed right now as the star's swollen atmosphere is causing the planet's atmosphere to inflate. And if you could stand on the surface of Kepler-91b, the sun would fill 36% of the whole sky right now.
It's just incredible. This planet, Kepler-91b, has that name for a reason. It was discovered by the Kepler spacecraft, which malfunctioned last year, but it might be getting a new lease of life.
Well, we're optimistic, yes. Since another of the planet-hunting spacecraft's reaction wheels failed in May 2012, leaving it effectively unable to point into the wider galaxy with the precision that it needs, new missions for this telescope have been proposed, but it looks like it could be set to start looking for exoplanets again due to an innovative method devised by NASA and the spacecraft's engineers. Now, this technique involves using the sun as the third reaction wheel, effectively using the tiny forces that photons from the sun exert as they constantly push against the body of the spacecraft. And this is a new technique, and it requires an even distribution of photons across the spacecraft. But an initial 30-minute imaging test produced an image quality within 5% of the primary mission image quality, according to NASA. So they just need to see if this will work on a more permanent basis. But from the gloom of losing this incredible spacecraft last year, it's looking more positive that Kepler may soon be back to finding more planets outside our solar system again.
This is Awesome Astronomy.
And now it's time for the 5-minute concept, where Paul tells you all you need to know about certain objects or concepts in astronomy that are either important to the way the universe works or pivotal in our understanding of the universe. And this month, Paul's talking about a relatively recent discovery that initially confounded astronomers and remains to this day one of the most important discoveries of the 20th century.
There's a band from the late 1970s called Joy Division. In 1979, they released an album called Unknown Pleasures. The album cover is a simple design, mostly black with a funny white pattern in the centre. If you look more closely at this rectangle, you will see it as a series of wavy lines that look more like a topographical map. You're in fact looking at one of the most astounding and important astronomical discoveries of the 20th, or in fact any century. This is the radio signal of PSR B1919+21. But let's not get ahead of ourselves. November the 28th, 1967. Charles de Gaulle had vetoed British entry into the European Economic Community. The Beatles had released Magical Mystery Tour in the US. And in Cambridge, a new type of star had been identified, one that redefined our understanding of the sky and the life of stars. It had been discovered initially in July of that year. The young Jocelyn Bell, a doctorate student working under the supervision of astronomer Anthony Hewish, had been analysing the data from the 4-acre radio telescope she had helped construct, and noticed something she described as a bit of scruff. The signal had a slightly greater than 1.337 second period, and a 0.04 second pulse width, and could be found at 19 hours 90 minutes right ascension plus 21 degrees declination, in the constellation of Vulpecula. Many, including Hewish, initially dismissed it as a spurious noise in the telescope, but as its regularity and persistence continued, other explanations were sought. Such was the regularity of the pulse, extraterrestrial explanations were even entertained, Bell and Hewish playfully labelling the signal LGM-1, Little Green Men. But what was it? It wasn't man-made. The signal followed the sidereal day, so it had to have an origin in the sky. It seemed to have a pulse so fast it appeared to rule out stars. Another instrument was focused in on it and found the same signal, so that ruled out instrumentation problems. Then another was discovered, and out went LGM, and in came pulsating star, Pulsar. It was the following year that the explanation of the phenomenon appeared, though many, including Fred Hoyle, had predicted their existence beforehand. Here was a neutron star, a star smaller and denser than a white dwarf, spinning at a terrific rate and emitting a pulse of radio energy. Spinning, though, doesn't even begin to describe what these bodies are doing. Think back to that pulse rate Bell and Hewish discovered, 1.337 a second. Here is a star with a mass almost half again that of the Sun, and has a rotation period of 1.337 seconds. Yes, it's smaller than the Sun. In fact, it's far smaller than Earth. But that just emphasises how massive these objects are. In this case, 1.5 suns packed into a space around 10 kilometres across. They have the densities of atomic nuclei. All this mass spinning in less than 2 seconds. And PSR B1919 plus 21 is a snail in the world of pulsars. PSR B1937 plus 21 rotates at an incredible 624 times a second. Its surface is moving at 1/7 the speed of light. Listening to the pulsations in audio really gives a sense of the vast speeds of rotation these objects reach. These recordings all come via Jodrell Bank and the University of Manchester. First, a pulsar rotating at 1.40 seconds, PSR B0329 plus 54. Then the pulsar in the centre of the Crab Nebula, rotating at 30 times a second. Then the second fastest pulsar recorded, PSR B1937 plus 21, rotating and emitting an incredible 642 times a second. And last, listen to the beautifully harmonised pulsars recorded from the globular cluster 47 Tucanae. But what is a neutron star, and why should they rotate at such vast speeds? Well, the neutron star is one of a range of stellar core remnants that we find littering the sky, heavier than a white dwarf, less massive than a black hole. At the point of stellar death in a large star, the core collapses, falling in on itself and creating intense pressures and temperatures. The core fights back at points with the pressure of electrons having one go, but ultimately failing. Eventually it's the turn of neutrons. Neutron stars are supported by quantum degeneracy pressure and something called the Pauli exclusion principle. In simple terms, this tells us that no two neutrons can occupy the same place and quantum state. Of course, the star itself was rotating before and during the collapse, and if you pull on some of that old school physics you have stored in the back of your mind, you may recall that as a spinning object brings mass close to the centre, it spins faster. Think ice skater pulling her arms in. So, as our stellar core collapses from millions of kilometres across to 10, then so these tremendous speeds are reached. Angular momentum goes relativistic. But what about the signal? How come we hear this pulse? Well, not all neutron stars are pulsars, though this may be a technical point. A pulsar is a neutron star that produces an intense magnetic field that creates a beam of radio energy as its poles. Of course, like our own planet, the magnetic poles do not have to coincide with the rotation axis. Get a pair of scissors if you can. Open them up, and with care, put one point on the surface and hold the handle of that blade vertically above. This is our rotation axis. The open blade and handle of the scissors are the magnetic poles of our neutron star. Now carefully rotate the scissors and imagine that every time the end of the free handle points at your eyes, that is the radio pulse sweeping across Earth. Of course, if you move your face to another position, then this doesn't happen, no signal. So, the pulsars we hear are a matter of chance alignment, like being in the beam of a lighthouse, and indeed this is how astronomers refer to this phenomenon, the lighthouse effect. Such is the reliability and regularity of pulsars, they have a potentially useful future in our spacefaring future, acting as perfect navigation beacons and timekeepers as we eventually move out across the solar system. If we take a small flight of fancy, it is amazing to ponder the idea that we are not alone in the galaxy, and maybe unbeknownst, as we blunder around our little corner of the Milky Way, we may be sharing a distant pulsing navigation beacon with little green men.
This is Awesome Astronomy.
So, following the tumultuous is it, isn't it worry over the possible cancellation of the BBC's flagship astronomy programme, The Sky at Night, we caught up with its presenter, Chris Lintott, to get the lowdown. So, Chris, most people know you best as a presenter of the BBC Sky at Night programme, and I'm going to come on to that in a moment, but first and foremost, you're an astrophysicist at the University of Oxford. What does the research side of your work involve?
A bit of everything, really. I'm easily distracted. So my main interest is in how galaxies form and evolve, and in particular how we get the mix of galaxies that we see around us in the present-day universe. But I also dabble in extrasolar planet hunting, bit of star formation. And the reason I'm able to do that is that all of my research involves what I call citizen science, but in other words, getting lots of other people to do my work for me, involving hundreds of thousands of people and sorting through the data that we get from some of the big surveys that we have access to, and collaborating with them to make the most of what we can try and find out about the universe.
Well, that allows us to delve a little bit deeper into citizen science then. As the zookeeper of this now constellation of science projects, citizen science projects, what was it that gave you the idea in the first place to do this?
Desperation, really. So it was sort of this time of year in 2006, just coming into 2007, been in Oxford for 3 months, and I was interested in looking in star formation in elliptical galaxies, because most elliptical galaxies are old, red and dead, but a few are still forming stars. We were interested in trying to work out what was special about them. But to do that, you needed to find a large sample of blue ellipticals. And it turned out that the automatic methods that people had of finding elliptical galaxies, deciding whether a particular galaxy was elliptical or spiral, those automatic methods couldn't cope very well. And there was a student here called Kevin Schwinski who looked at 50,000 galaxies and proved both that it's worth having people do this task of sorting galaxies by their shape, and also that 50,000 is sort of the limit for a student. And so we were sitting in the Royal Oak pub just down the road from here talking about this, and decided that we would ask for help. And pretty soon afterwards, we created a website called Galaxy Zoo, and the response was overwhelming, and the rest, as they say, is history.
And can you tell us, who is it for now then?
We want everyone to get involved. I want to use up all of your spare time and all of your listeners' spare time. So it turns out that this problem of having too much data, we had too many galaxies. But this problem of having too much data is happening right across astronomy and right across science. And so if you do have a few minutes spare, you can go to zooniverse.org and within a couple of minutes be seeing images that no one's ever seen before, and doing things that actually make a contribution to science. And you don't need to be an expert to do this. You don't even need to know anything about astronomy. I'm sure most of your listeners are incredibly well informed, and susceptible to flattery as well. But no, I think this is the amazing thing. We're at a point in science where it's this highly technical, complex sort of mix of people and machines and facilities, and yet just by using a web browser in a few minutes, you can actually make a difference.
And it's also great fun too. And
I think so, yeah. Yeah, I get distracted by some of our non-astronomy projects. So the astronomy ones are obviously dear to my heart, but when you have the chance to classify plankton, I recommend you take it. Plankton turned out to be hugely fascinating.
Oh, well, you've just mentioned there about the plankton. You've also got the looking through Kepler data. There's also Kuiper belt objects. There's the sifting through galaxy types. How far do you think citizen science can go in terms of what the public can do in the future for science?
Well, I think much further than we suspected. So with Galaxy Zoo, we started off trying to ask the simplest useful question. So is this a spiral or elliptical? But we quickly realized people could do much more than that. And actually, lots of our volunteers go on to do their own research. In Planet Hunters in particular, lots of the interesting discoveries in Kepler data have come from advanced citizen scientists following up on discoveries themselves. I think the future of this is bright, frankly. We've got facilities that we could see coming down the line that are going to overwhelm us again. So whether it's something like the Square Kilometre Array, which is the next generation radio telescope, or the LSST, which is the next big optical survey telescope, an 8.4 metre that's going to scan the sky every 3 nights. Mm-hmm. And that's going to give us, straight onto the web, reduced data, something like 30 terabytes a night. And so what we're working on is trying to work out how to make sure volunteers get a piece of that. So I think the future is combining classifications like those from Galaxy Zoo with machine classifications and having the two work together. So most of LSST's output might be processed by computer, but those computers might know when to ask for help. They see something unusual, for example.
And so far, how have the public's observations on computer screens helped the professional world of astronomy to date?
Well, that's another 7-hour talk, really. So I mean, you could just stack the papers. So there are about 100 papers using Zooniverse data already published. But I think you can sort them into two sort of categories. One is the times when people have found things that we were looking for. So I got my sample of blue ellipticals. We've gone and looked at them, and they show signs of having interesting interactions with the black holes at their center. In Planet Hunters, we've discovered about 90 planet candidates that were missed, many of them in the habitable zones of their parent stars. But you also have a second set of discoveries, which are the points where people have done that very human thing and become distracted by what they're looking at. So, for example, in Galaxy Zoo, we had the discovery of these small, round, green galaxies, which are the Galaxy Zoo Ps, that turn out to be the most efficient stellar factories in the local universe. But no one knew they were there or that they were interesting until some of our volunteers said, hang on, there's something funny about these systems. And we see that in project after project after project. It's both, yes, give us a few minutes and click some buttons and help us sort through this massive data. But it's also this very human thing of being distracted by the weird stuff that produces real scientific discovery.
And there's also the payback as well, isn't there? That people that are doing this sifting through the data for you also get the potential to have their names cited on research papers.
Absolutely. I'm never sure whether that's much of an incentive for anyone who isn't a professional. But yeah, we have about 60 people who've had their individual name on a paper because of work that they've done. We also give credit, so every paper has a link to a very, very long author list. We did try to get the journal to let us publish a paper with 250,000 authors, but they weren't really up for that. That's longer even than the particle physicists. But no, at Galaxy Zoo or going to one of the other Zooniverse projects and giving us a couple of minutes, you will be advancing what we know about the universe. Like most science, it's not always discoveries and excitement. Sometimes it's just yet another blobby elliptical. But that's all part of the process. And I think there's something really special about the fact that you can do that without any preparation and without any equipment. You know, when I grew up I grew up as an amateur astronomer with a small telescope, and I desperately wanted to do something useful. So I used to sketch Saturn and send those forms off to the BAA or count meteors or something like that. But the truth is that amateur astronomers today who are making real contributions, fabulous though they are, have spent quite a lot of money on kit and are already the advanced amateurs. Whereas the nice thing about Zooniverse is that on a whim, you can find yourself doing something useful.
And without any knowledge of astronomy whatsoever.
Exactly, yeah. We forgot on the original Galaxy Zoo site, we didn't even bother to explain what a galaxy was. And we're a bit better than that now. But the point is, these are tasks that could grip anyone. And we can see what happens. Once people realize they're doing something real, then they become highly motivated to find out about stuff and to find out more about the subject. So I think they're very exciting projects, both from a research point of view, but also because they're a way of talking to hundreds of thousands of people about how science actually works.
Yeah. And something else that's exciting, we've heard that the Sky at Night programme on the BBC will thankfully continue now. There's going to be a few changes. So what can you tell us about Sky at Night Series 2?
Yes, yeah, we're calling it Series 2 because, as you know, we're taking a month off,
yes,
which after 57 years perhaps is deserved. I hope Series 2 will run for as long as Series 1 did.
Yeah, fingers crossed.
So the main difference is that we've got a new addition to the team. Maggie Adair-Pocock's going to join us, which I think is fabulous. Because
yes, great addition.
And she brings in some... We've always had expert presenters on Sky at Night, but Maggie, of course, is expert in a different way from the rest of us, in that she builds stuff or has built stuff that goes to space.
Yes.
And so we'll have a bit more of that space science expertise, which I think is really exciting. If you look what's happening in the next year, we've just had Gaia launch, we've got Maven arriving at Mars, we've got Rosetta arriving at Comet Churyumov-Gerasimenko. I hope that's how you say it.
Don't pronouncing that.
I've got to practice. This may be the first time I've said that publicly. These are all missions that are about science, but they're also about spacecraft and about spacecraft doing things. And Maggie will be a great addition for that. Other than that, a change that matters more for our point of view, but I think you might notice is we're moving. We have been happily based in BBC Bristol until recently, and we've been moved to London, where we'll be with the rest of the science programs for the first time in the Sky at Night's history. And so I think hopefully that will enable us to be a bit more flexible and do a bit more than we would otherwise have been able to. So I think you should see a few more stories and a few more deep background interviews and so on that we wouldn't have been able to get otherwise.
Mm-hmm. And sadly, Jane Fletcher, the lovely previous producer, won't have her fingerprint on Series 2. So what do we know about the content going forward? Will the show maintain its hallmark integrity, do you think?
Well, it better. Otherwise, they're going to have words from me. I'm sure it will.
Right.
So, yeah, the Sky Knights, the hidden powers behind the Sky Knight, the people who really make the program. I mean, I'm happy to take all the credit when talking in public, but it's actually the producers who matter. And there have only been, in the show's 57-year history, there have only been 8 producers. And so it's a big job. You think of people like Paul Johnstone, Peter Mpergo, who did it for 20 years, and then Jane, who started in 2003 and has taken it to where we are now. So no, I think the producer is important. The new guy's a guy called Rob Liddell. I've met him. I'm very impressed, and I think I think we're in safe hands. I hope you lot agree when you see the first programs in February.
Well, we're glad to hear that you think it's going to be in safe hands, well, we'll judge it when we see it, I guess.
Sure, maybe we should have a chat after the first programs have gone out.
Yes, we'll get a focus group together for you.
Sure, I'd love to do that.
It's a great time to be embarking on a new era, I think, because with the Chang'e 3 rover on the moon and Mangalyaan, and you mentioned Maven earlier, and Gaia and all the other craft that are going up into space, it really does seem right now as though space is in a renaissance at the moment, doesn't it?
Yeah, I think astronomy is in a renaissance, whether it's in the exploration of the solar system, Curiosity, of course. I mean, we could probably make Curiosity at night for the next 2, 3, 5 years and not run out of things to say. Cassini, of course, still going well. So there is a lot going on. I think if you look beyond that, the exoplanet discoveries from Kepler, which we're still struggling to understand, plus the sort of battening down the hatches on cosmology and galaxy formation. It is a great time to be an astronomer. I think as professionals, I think there's a danger in being slightly complacent. There are pretty much everywhere you look, there are funding problems. Mm-hmm. And I think we need to make sure we keep the visibility of all of these things as high as possible, because that's what our politicians care about. And if we want them to keep funding astronomy and space science, we need to make these things not just successes, but high-profile successes.
Yeah, I think that's crucial, that keeping up the pressure on our representatives and people in government that can actually fund these things. They need to know that the public are interested in this.
Yeah, exactly. And there's a sociological thing here. As we get more ambitious, the number of different things we get to do decrease. So, in the old days, we could afford to have an optical telescope, a UV telescope, an X-ray telescope, and an infrared telescope in space. But now the budget for any one of those would happily consume all of the others. So There's also, I think, on our side, as we argue about what we should fund, I think we need to be careful of not throwing everything out together.
Yeah.
And I think, we talked earlier about the relationship between professional and amateur astronomers. I think and that's something you guys can help us with, because amateur astronomers are both the advocate. These are the people who, occasionally I get up on a stage and I talk to 200 people about the excitements of Kepler, but actually, it's the voices of the amateur astronomers that are heard in schools and in their communities. And so there's that advocacy, but also going the other way. We should be picking things that get our loyalist fans excited. And I think that process needs to work both ways.
Yeah, and it can be a surprising quarter as well when you have people from the public that aren't expected to necessarily to be the big advocates really coming out and focusing their energies. We only saw with the Save Our Sky at Night campaign recently just how much of an impact things like that can have. Yeah,
or the Hubble repair mission as well. So NASA had declared that towards the end of the shuttle program that it wasn't possible to go and save Hubble. And the outcry of the US was such that it drove a political decision to find a way to make that happen. And so we've got 5 years of Hubble that we literally wouldn't have had it not been for a public outcry. And so we have that. It's a huge advantage for us in astronomy. But, astronomy is something that people are interested in. We're the gateway drug to science for a lot of people. And I think we need to make the most of that. Sorry, it's supposed to be Christmas and New Year, and here I am talking about funding, and it's all very depressing.
Okay, well, let's move on to something that's maybe even more in the public attention than manned spaceflight. Do you think that the manned ambitions to get a Chinese taikonaut on the moon by, I think it's 2030, and an American astronaut to Mars in the 2030s is going to spark another era of accelerated manned space exploration?
What, because there's a space race between the two, you think?
Well, I don't think it's going to be quite a space race, not in the same way as it was with the Americans and the Soviets, but kind of one-upmanship, shall we say.
Yeah, the trouble is this is a political question, and the only thing that's been missing for the manned space program over the last 30, 40 years is political will to go and do something. Whether China can inspire that in the US, I don't know. The US political system is much harder to understand than the formation of galaxies. So I'm not sure I'm going to make any predictions. Well, I think on the Chinese point, I've been incredibly impressed by how fast their program is progressing. I was writing my column for Sky Night magazine this morning, and I was just looking back to 2007, which is just before Chang'e 1 launched. And, back then, no one would have bet on this rapid progress. I mean, that lander that put the rover down could have carried a much more heavy payload than it did, much more massive payload than it did.
And we expect the Chang'e 4 to do that, don't we?
Yeah, exactly. And then sample return, which is when scientists really start getting excited, coming up for number 5. Chang'e 4 is going to do re-entry testing as well. And so I wouldn't bet against the Chinese doing. I mean, they've said they're ambitious to put a man on the moon, and I could certainly see that happening. Mars, I think, is probably beyond the politicians' reach. I can't see them coming around to it, but I do take heart from people like Elon Musk. A lot of the private attempts to go to Mars that get talked about seem to me to be worse than vaporware, to be completely nonsense. But SpaceX are serious, I think, and have shown that they can do interesting and unusual things. These days, they have a commercial model. They can now put commercially valuable satellites in the appropriate Earth orbit. So they have a stream of cash, which, if they want to, they can spend on developing things to get their founder to Mars. So I think my bets are Chinese for the moon and probably SpaceX for Mars.
Right.
But I wouldn't be putting a deposit down unless you're extremely wealthy.
And finally, a question we ask everyone we interview. If there was one thing you could discover about the universe research-wise, what would it be?
Oh, this is tricky. Because there are the big questions. Like, it's tempting to want to know what dark matter or dark energy is.
Okay, well, let's run with that.
Oh, well, those are possibly two answers. But I think those are less fun. I think I'd like to discover. It has to be life. It has to be an Earth-like planet with life. I think that changes everything we think about the cosmos. And
of course, discovered through planet hunters.
That would be ideal. I don't know how we'd find out. Maybe life through our SETI project as well. But yeah, life in the universe, please, because that resolves a lot of questions and opens up a whole set of new ones.
Okay, well, thanks very much, Chris Lintott. It's been wonderful speaking with you.
My pleasure. Talk soon.
This is Awesome Astronomy.
Well, this is the part of the show when we look over the questions you've sent in and pick out a couple that pique our interest, help explain issues we've not covered before, or relate to topics we want to cover in more depth. And if you want to send a question in to us to discuss in future shows, you can tweet them to @AwesomeAstroPod, or post them on the Awesome Astronomy Facebook group, or email us at theshow@awesomeastronomy.com. So, Paul, this month you've chosen to explore clusters from a question which comes from Andrew Burns via email. And Andrew asks, "Hail alien overlords." That's going to get our attention, isn't it? I have a question. What is the difference between an open and a globular cluster? Is it just that globular clusters are more massive and stick together? And are there intermediate objects? Actually, I suppose that's 3 questions. So, Paul.
Okay, well, perhaps it's important first to get a little context on where these objects are found and how big they are. So that will go some way to answering this question. So let's start with my favourite sky object, globular clusters. Now, these are wonderful enigmatic objects that are stunningly beautiful and not entirely understood. They're found in an area of what's known as the galactic halo, and they're usually concentrated around the centre of the galaxy if you view it from outside, especially edge on. This halo is an extensive bubble around the galactic disk, so in some respects you can think of globular clusters as being outside the traditional galaxy, little islands of stars orbiting the Milky Way. I say little, but that's a perspective thing, and typically globs are tens of light years across. Around 80 light years across is typical, while the larger ones are over 200 light years across. Now, the fact that they mainly appear like fuzzy stars demonstrates how far away these objects are from Earth. the nearest being NGC 6397, which is 7,200 light years away. The famous M13 is about 22,000 light years away, and one of the furthest, NGC 2419, is a staggering 300,000 light years away. Now, open clusters, on the other hand, are much closer. The nearest, the Hyades in Taurus, being a pedestrian 153 light years away. So these objects are found within the galactic disk, and where it's thought there are maybe 180 globs around the Milky Way, there are probably at least 1,100 open clusters that we know of within the arms of the galaxy. They're also tiny compared with globs. The Hyades is just 10 light years in radius. Now, there are some key differences in composition between the two that illustrate why they're very, very different. The first is the number of stars. A globular cluster has stars numbering the very least in the tens of thousands, and the larger have star counts approaching 1 million. With open clusters, we're looking at star counts in the hundreds. Then there's the age difference between the two. When we look at the age of globular clusters, we're looking at some of the oldest objects in the universe, with ages that suggest many of them formed in the earliest eras of star and galaxy formation, over 12 billion years ago. With open clusters, we're looking at ages in the hundreds of thousands and millions of years, babies in the great scheme of things, typically far younger than our own sun. Open clusters are where stars form from molecular clouds, and over time these new stars disperse. Our own sun would have been a member of an open cluster that's long ago dispersed. So to summarise, globular clusters are in effect mini-galaxies, satellites of the Milky Way. They are ancient and massive, a ball of thousands of stars that are gravitationally bound together. Open clusters are loose associations of sibling stars, stars that are formed together in a cloud, such as we see happening in the Orion Nebula. And over time, with some notable exceptions, and I'm looking at you, NGC 188, they disperse, with the stars going their own separate way. So globs appear to be a long-term, essentially permanent galactic feature, while open clusters are a stage in the evolution of stellar nurseries and are transitory, lasting no more than a few million years due to their gravitational bind being unstable. And of course, Andrew asked, are there intermediate objects? Well, not really. I think you need to view these two as only having a word in common. But that said, there is a large irregular cluster of stars called Westerlin 1 that we think is in the process of becoming a globular cluster. Not an intermediary, certainly not an open cluster, but demonstrates that there is far more to find out before we have an understanding of these things we find in the sky.
So very different beasts altogether then. And our second question this month comes from Ray Bonner via the Facebook group, and Ray asks, does Mars have periodical meteor showers? And given the thinness of your atmosphere, are they like carpet bombing from space? Okay, so the simple answer is yes, we get periodic meteor showers, and no, we don't get carpet bombed. Because just like Earth, Mars's orbit takes it through dust trails that 4.5 billion years of comet and asteroid journeys leave behind, most notably Comet Linear and Comet Halley. And a Montana State University research paper from the year 2000 called Determination of Meteor Showers on Other Planets Using Comet Ephemerides suggests that Mars likely receives at least 5 meteor showers each year, and Jupiter gets a whopping 148, at least 24 at Saturn, 6 at Uranus, and 1 at Neptune each year. Now, because the surface atmosphere on Mars is only 1% the thickness of Earth's, it's tempting to think that all this debris will just whiz through the atmosphere and strike the ground. But it's not as simple as that, because Mars's less dense atmosphere extends further out into space than the Earth's tightly bound atmosphere, largely due to the red planet's lower gravity. And about 100 miles up, where the meteors begin to burn up, the atmospheric densities are roughly the same. And later this year, as we've mentioned in a couple of earlier episodes, Comet C2013 A1 is going to pass within 100,000 miles of Mars, less than half the Earth-Moon distance. And due to the bloated coma and tail of the comet, we expect an impressive meteor shower on the red planet on the 19th of October, as all this cometary dust burns up in the atmosphere. Now, hopefully a barrage of spacecraft will be able to image this meteor shower from the ground and orbit as the first such display ever recorded on another world. But the upshot is that on Earth or Mars, there will be annual meteor showers, and unless there are larger particles left behind by comets that intersect Mars's orbital path, they're going to be no more dangerous on Mars than they are on Earth.
This is Awesome Astronomy.
Well, that's all we have time for this month. If you like the show, please do leave us a review on iTunes and listen out for us and all the other excellent astronomy shows on 365 Days of Astronomy. And if you want to leave us any comments or questions for the show, you can tweet them to @AwesomeAstroPod, post them on the Awesome Astronomy Facebook group, or email us at theshow@awesomeastronomy.com. Look out for the next Sky Guide a few days before the start of February on iTunes, the Awesome Astronomy YouTube channel, and our website www.awesomeastronomy.com, and we'll have the main show ready for the usual start of the month. So until next time, it's goodbye from Cydonia Base. Awesome Astronomy is produced by Ralph Wilkins, Paul Hill, Damien Phillips, and John Wildridge, and is free to distribute for educational purposes. Music is courtesy of Star Salzman. For more astronomy news, views, help and advice, visit our website at www.awesomeastronomy.com. You can join in the astronomy discussion on our Facebook group, and you can follow us on Twitter @AwesomeAstroPod. We invite your questions to read out on the show. You can send them to us via Facebook, Twitter, or by email at theshow@awesomeastronomy.com. We thank you very much for listening. From Cydonia Base, end of transmission.
I'm just going to take a beer for a minute. Just pause.
Just pause and reflect on how badly I'm doing.